In this video, we will discuss function composition. And function composition is where one function is composed of another function. So basically, you're putting one function inside of another function, or sometimes you're putting a function inside of itself. Okay, we'll have an example later with that. As you can see here, if we are doing f of g of x, we are putting the g of x function inside the f function as they're indicating down here, okay? And x is your input of g, and then you have to figure out what is going on with the g of x function for that input, and then you use that output of g of x as your input for f. All right, it'll probably make more sense when we get to some examples. One thing I want to make sure is you make a note of is when you have f of g of x, okay, we do think of this as f of g, all right, but we have to be very, very careful that you're not getting it confused with f times g of x. So this would be where you take the f of x function and you multiply it to the g of x function, which is not the same. Okay, these are not the same, very different calculations. So order of operations is very important when you do function compositions, and this example here is showing you that. They're giving you an f of x function of x squared and a g of x function of x plus 2. The first example here is where they're showing you f of g of x. So they're taking the g of x function, which is that x plus 2, and they're putting it inside the f function, which is x squared. And then you have x plus 2 squared, as you can see here. And then they're just simplifying that. Let me just remind you that x plus 2 squared is x plus 2 times x plus 2. And then you want to FOIL this out, and that'll be x squared plus 2x plus 2x plus 4. And that is x squared plus 4x plus 4. So that is the simplified answer. The second part here is where they're doing g of f of x, and they're putting the f of x function, which is x squared, inside of the g function, and that gives us a result of x squared plus 2. Okay, so order of operations is very important. As you can see that what we got here for f of g of x is totally different than what we got when we did g of f of x. So be very careful that you're following the correct process for putting one function inside the other, and you do not get the order interchanged. Here's an example where they're giving you a table. All right, and in the table we have an f function and a g function. And just to kind of help you understand the table, if your f function has an input of 1, then it has an output of 6. That's what that means. And let's say if your g function has an input of 3, it has an output of 2. All right, so that is just helping you to understand what this table is giving you as far as information. And if we find f of g of 3, so f of g of 3 means we need to first figure out what is g of 3. Well, g of 3 would be using an input of 3 in the g of x function, which gives us an output of 2. So g of 3 equals 2. Then I take this result and I use it as my input in my f function. So my f function, okay, my f function input of 2 has an output of 8. So f of g of 3 equals 8. Right, and you have done that composition using these functions. Okay, let's try the other one here. So the other one is g of f of 3. So g of f of 3. In fact, I encourage you to pause the video and try to do it on your own. And then you can play the video to see how you did. So first you want to find f of 3. So you want to go to your f function, input of 3, look at your output, which is 3. And then you want to use this output as your input for the g function. So now we will go to our g function, input of 3, which has an output of 2. So g of f of 3 equals 2. And you have finished that composition. It's actually a little fun, I think. Of course, I love math. I don't know if you think that's fun or not. Maybe you do. I hope you do. Let's get into the algebra. So when we get into the algebra of the functions, it gets a little bit more difficult because you do have to think about your domain in addition to the composition. So in this first example, we're given an f of x function of square root 1 minus x, g of x function of 3x plus 2. They want us to find f of g of x. So that's putting the g function inside the f function. So I like to rewrite that as f of 3x plus 2. So you're just taking this g function and you're putting it inside your parentheses here to indicate this is my new input for the f function. Then I'm going to go to the f function, and wherever I have a variable, I'm going to stick the 3x plus 2 in there. So I'm going to have square root of 1 minus, taking out this x up here, replacing it with the 3x plus 2. Make sure you use parentheses there. And then we simplify this expression. So in this case, the subtraction will distribute through, and then we can simplify that to negative 3x minus 1. This is the answer for the composition. So that's the answer to part A. Part B is where we find our domain of f of g. Over here in this chart, they're explaining how to do the domain, right? And you have two steps to doing domain of composition functions. You first think about the domain of the inside function, and then you think about the domain of the composite function. So there's two layers to the process. Sometimes if you skip one part or the other, you will get the wrong answer. Okay, you have to be very, very careful that you're thinking about both parts, putting both parts of those domain together, and then writing a final answer. So our inside function is g of x. So if I want to think about my domain of g of x, I am thinking about the domain of this 3x plus 2. Well, this is just a linear function. You could throw that on Desmos if you needed to. And my domain is going to be negative infinity to positive infinity. Then I want to think about the domain of the composition. So the composition of f of g of x is this outcome we got over here. And then I need to think about how to do my domain there. Well, since we have the square root function, as we already know, I need to think about values that keep this greater than or equal to 0. And we need to solve this. And my domain is going to be all x values that are less than or equal to 1/3. In interval notation, that is parentheses, negative infinity, comma, 1/3 bracket. Then I think about these two together. So I had negative infinity to positive infinity, and then I have this result. I layer these two together to make sure my domain is going to meet both of these criteria, and then I come up with a final answer. So in this case, since the first domain is negative infinity to positive infinity, there's no restrictions there. That's all real numbers. So whatever I have for this composition is going to be my final answer for part B here. All right, moving along here, we're using the same two functions, but we are switching up the order. So now we're doing g of f of x. So g of f of x is where we're going to put the f of x function inside of g. My f of x function is the square root of 1 minus x. Okay, so I've got this and I'm sticking it inside here. Then I need to go to the g function, and where I have an x, I'm going to put in the f of x function. So that is going to be 3 times this square root of 1 minus x plus 2. And to simplify this, I really can't do much except for drop those parentheses. You can't distribute the 3 here, and you cannot add the 2 to the 1. So this is as far as the expression will simplify. Domain, remember, do this in two parts. First, think about your inside function. So your domain of your f of x, you have square root of 1 minus x, so we know we need to put the 1 minus x greater than or equal to 0. Then solve this, and I need to use x's that are less than or equal to 1. That's going to be negative infinity to 1 bracket. Then think about your domain of your composition, which is the g of f of x. And the result I got there is the 3 square root of 1 minus x plus 2. And in this case, we would still just think about the square root here, which is the same process we used here, and we're going to get the same resulting domain. So since these exactly matched up with each other, that's obviously going to be my final domain, which is the answer to part B. All right, our last problem here is where they've presented us with an f function and a g function, but they're saying find g of g. And this is where you're going to put the g function inside the g function. So we're going to do g of x. And you want to first just think about taking this 3x plus 2 and putting it inside the parentheses here, which is saying my new input is going to be 3x plus 2. So I need to go to my g function, and where there's an x, take that out and put in the 3x plus 2. So I'm going to have 3 times 3x plus 2 plus 2. And then I simplify this down. I need to distribute the 3 and then combine like terms. So 9x plus 8. And for the domain on this one, the g function is linear. So it's negative infinity, positive infinity. And then the domain of the composition, g of g, is also another linear function. So that's negative infinity to positive infinity. Once again, if these are the same, that's going to be your answer to the entire composition. These take a lot of practice, okay? So that's where the lab manual, the WebAssign, and asking questions comes into play. Also, don't remember you have a textbook, and the link is shown down here. There's lots of great examples in that textbook that you can look at if you need some more help, and ask questions if you have them. I'll see you online.